and I'm going to add 1 to the exponent, and then divide by that new exponent. And of course, make it plus c. So I end up with negative u to the 4/3 power, divide by 4/3. I'm just going to continue to say plus c because I'm adding a constant. My constant is just any value at all. If I divide by 4/3, I multiply by its reciprocal. So I have negative 3/4 u to the 4/3 plus c. I'm not finished though because I must write it in terms of the original input variable. So this now is my second substitution. So substitution number 2. I'm going to write my indefinite integral as negative 3/4 u. Now u has a value of 1 minus 2x squared. So 1 minus 2x squared to the 4/3 power plus c. Again, how do we check this? Well, if we take the derivative of this problem, negative 3/4, 1 minus 2x squared to the 4/3 power plus c, if I take that derivative of that, and I don't want to write it exactly like that because that was not an equivalent statement, I would have, though, negative 3/4 times, and now I would have 4/3, 1 minus 2x squared to the 1/3 power, subtracting 1, times the derivative with respect to x of the inside function plus c. Well, actually, the derivative of c would be plus 0. Okay, so simplifying this, we would have negative 3/4 times 4/3. Now, that's going to equal negative 1. Times 1 minus 2x squared to the 1/3 power times negative 4x, and of course our plus 0. As I said, these are going to cancel. Our negatives are going to cancel. We end up with negative 4x times 1 minus 2x squared to the 1/3. And again, the negative in front and the negative there cancel, so it's a positive. How does that compare to our original integrand? Well, it is the same thing. Okay, let's go on to the next problem. Okay, next problem. Indefinite integral. We have this trinomial times this binomial times the differential. Again, we are wanting to look for a composite function. The function may not appear to be composite. However, we're going to also look for, let's say, the more complicated portion of this. And the quadratic is more complicated than the linear. So let's let u equal 7 minus 3x minus 3x squared. Let's take the derivative of that. And this would be negative 3 minus 6x. Multiply both sides by the differential of dx. We have negative 3 minus 6x dx. And if we look up here, we are needing to have a value that represents 2x plus 1 dx. We have negative 3 minus 6x dx. So all we're going to do here is I'm going to factor out a negative 3. That would give me 1 minus 1 plus 2x dx. And then if I multiply both sides of the equation with a negative 1/3, and then I can turn these around if you'd rather see it that way, 2x plus 1 dx. Now if I look at my problem and I do the first substitution, I could substitute this as u, being this quantity here, times negative 1/3 du. Again, this is a scalar. It can come out in front, so I have 1/3 the integral of u du, and I can integrate that, find the indefinite integral of that as 1/3 times u to the 1 plus 1 power, divide by 1 plus 1, plus c. Or simply, u squared divide by, and this is 1/3 times this, divide by 2 plus c, or u squared divide by 6 plus c. Again, I have it in terms of u. I need it back in terms of my original input variable of x. So I do substitution number 2. And my antiderivative is going to be, u has a representation of 7 minus 3x minus 3x squared, all of that divided by c, or by 6, plus c. Now, if that's true, and we check this, we would have, and we might want to write this as 1/6 times that quantity plus c. So if we look at the derivative of x, derivative of f of x, we would have 1/6 times, and this would be the derivative of negative 3x is negative 3, derivative of negative 3x squared is negative 6x plus 0. So we would end up with, this could be negative 1/2 minus x. Okay, obviously we're not getting the right answer, and I've been just checking here. Some of you might have caught it before. I forgot that I've got u squared. So this quantity is to the second power. So to the second power. So let me go back and work this then the way that it should have been. So let's erase our work here and continue then working this the way it should have been. So we should have had 2 times the quantity of 7 minus 3x minus 3x squared times the derivative with respect to x of 7 minus 3x minus 3x squared. So we're taking the derivative of the outside function, leaving this to the power of 1, and then times the inside function. So now let's see if we get the right answer. So this would be 1/3 7 minus 3x minus 3x squared times, and the derivative here would be negative 3 minus 6x. And here is our 7 minus 3x minus 3x squared. And if we multiply through by a negative 3, we would end up with negative 1 minus 2x. Okay, not getting too good here. I forgot another sign, so let's go back and put that in. We had a negative right here, and I dropped that. It should be a negative and a negative and a negative and a negative. Let's continue on here. So that would be a negative and a negative, and we would have a negative and a negative and a negative, which would then make these signs, if we multiply through, it would make then these signs then all become, and we would have 7 minus 3x minus 3x squared times, multiplied through by a negative, 1 plus 2x. Let's go back and recap this since I made a couple of errors there. The basic premise of this is that we are going to look for a way to make a substitution. Now, we could have multiplied those through and come up with a polynomial, and it won't work with all problems. I mean, it won't work with all products here, but it did happen to work with this one. It was written very carefully, that the quantity 7 minus 3x minus 3x squared has a derivative that when you factor out a negative 3, you end up with the 2x plus 1. So the substitution is made that we are going to, in place of the trinomial, we put the u, and in place of 2x plus 1 differential x, we put negative 1/3 differential u. Integrate in the same way. Come down and replace then the u with the value of its replacement, which is 7 minus 3x minus 3x squared. And then you can see the need to check this one way or the other to check your work. And in the check, I realized that I had forgotten a couple things. One is I hadn't carried down that it was the quantity squared, and then realized that I hadn't carried down that we have a negative. So a check, whether you do it on the Inspire or if you do it by hand, as we did here, is very important. Let's take a look at the Inspire and make sure we remember how to do that. Go to Menu, Calculus, and Integral. Now with these indefinite ones, we are not going to fill in. This is prior to our section 5.4, so this was before we were looking at the fundamental theorem of calculus. So we're just going to ignore those. And I'm going to put in brackets, and let's see, it was 7 minus 3x minus 3x squared, and move outside that initial set of parentheses, and we're going to multiply then by 2x plus 1. And remember, you always must identify that input variable of differentiation, and we press enter, and we do get our negative 1/6 this quantity squared. Let's go back and make sure that's what we had. Negative 1/6 that quantity squared. Okay, well, let's go on to our next problem. Determine the indefinite integral, and again, do a check on this. Now, if you look at this, this is a true composite function again, and we have a quantity with the square root of that. If we are looking to decide what to let u represent, again, let u represent the inside function. So it would be x cubed plus 3x plus 4. Take the derivative with respect to x, and we would have 3x squared plus 3. Multiply both sides by the differential, so we have 3x squared plus 3 dx. And take a look up at our problem. Let's rewrite this. We end up with x cubed plus 3x plus 4 to the negative 1/2 power. And then we have x squared plus 1 dx. So if I look at this final part here, do I have the same thing down here? Well, I do if I factor out a 3, so I'll do that. And then if I multiply both sides by 1/3, so I have 1/3 du equals x squared plus 1 dx, I do now have the same thing. So I'm going to make a substitution, and I'm going to write this as u to the negative 1/2 times 1/3 du. The scalar 1/3 can come out in front, and so I'd have 1/3 the indefinite integral of u to the negative 1/2 du. When I take the indefinite integral of this, I would have 1/3 times, and again I add 1 to the exponent and divide by the new exponent, plus c. Let's see, this is 1/3 And we have here u to the 1/2 divided by 1/2, 1/2 plus